Well, it's 9 o'clock. We might do a quick sound check. Can everyone hear me okay?
Yep, all good on my end.
Yep, all good.
Oh, good. Thank you. So I can see Ryan and Amy and Wayne and Andrew and Lewis and Jared. Lots of familiar faces from last term, or familiar names. Okay, so this week we're doing polymorphism. Sounds scary, but it's actually continuing on from what we did last week. Okay, so polymorphism. So last week we did inheritance, and this week it's all polymorphism. And the week 1 and week 2 videos are on my YouTube and my Mike's Java videos if you're looking for the week 1 and week 2 class videos. I need to go back and edit the week 2 video to add in the sound that was garbled. There's a lot of sound that was garbled. I need to go and re-record that when I get a chance. Okay, some clarifications from last week. So the call to the superclass constructor must be the first Java statement, but you can have comments before. So this is quite okay. There was one language I worked in when you couldn't even have a comment there. That wasn't even okay, but Java's not that language. Okay, so you can have many comments, but the first Java statement or the first line of code must be a call to your superclass constructor if you want to call it. If you don't want to call it, you don't have to, but if you need to call a superclass constructor, it must be the first Java statement. It's always a good idea to use override when you can. So for example, the equals method in last week's slides didn't have an override on it. It's always a good idea to use override because that's a method in the object class that we're overriding, just like we do with toString. We put an override before toString because it's a method in the object class that we're replacing with our own method. Okay. This wasn't mentioned in last week's slides, but it's important. And in Java, so in Java, it's not the same in other languages. Each class can have at most one parent. In other words, one superclass. So if you try to do this sort of thing, where you've got public class followed by extends class 1, comma class 2, that would be an error. You can only extend one class. So you can't have two parents in Java. Some languages you can. Some languages you can have as many parents as you like, but not in Java. Okay, so I just thought I'd make those clarifications from last week. A quick review. So last week I said one of the most important tutorial questions you'll do this term is the vehicle, cars, trucks, and we'll come on to that shortly. But let's just talk about the manager and employee. So we'll talk about these in last week's lecture. So we had public class employee, and which didn't extend anything, and then we had public class manager extends employee. So which of these is correct and why? So see if everyone can have a go here and see which ones are correct. So you've got to think about your is a relationship. Which way does the relationship go? Is it down or is it up? Okay. Think of that little diagram we looked at last week. Okay.
Pretty sure it's the fourth one isn't right.
Okay. Yep. That's exactly right, Wayne. Okay, so E1's got to be right. We're just declaring an employee to be an employee. That's got to be right. So we can knock that one out straight away. Manager equals new manager. We can knock that one out straight away. Of course, that's got to be right. And these two are the tricky ones. And you've got to think about, am I losing data or do I have enough data? So if there's too much data, Java's happy to truncate it. But if there's not enough data, it can't create the object. Okay, so manager had the bonus and we're trying to store the manager, which has got the bonus, inside an employee object, which doesn't have a bonus. So we're losing data. So there's truncation happening. Okay. Yeah, so you got to think about it. You got to think about it because that one is actually the error because again, we don't have enough data to make a manager. Okay, we don't have enough data. employee doesn't have the bonus, so they can't be a manager. Okay, because if we try to say e4.get bonus, there's no bonus there to get. Okay, so truncation's okay when you're chopping off data. So when we store a manager in an employee, you know, at worst we're chopping off data, we're losing the bonus, but here we don't even have it. So this would be the error. Okay, so the other three are all okay. So you've got to think about is a relationship. It's employee, or a little diagram, or what we had in last week's class, manager, and we're going down the hierarchy. The employee is a superclass, the manager is a subclass. So is a relationship going on. So going down's fine. It's when you go back up again, things aren't okay. So manager to employee, not okay. Employee to manager, no worries. Okay. The worst that can happen if we try and treat a manager like an employee, the absolute worst that can happen is we lose some data. Okay. But here we're trying to call an employee a manager, and we don't have the data, so we can't create the object. Okay. There's something missing. We can't do it. Okay, so that's very important to keep in your mind as we move forward. We're going to be doing that all through the rest of the term. So you've got to really make sure you got your head around that. And it is easy to get it wrong. You got to stop and think. I always find it helpful to draw a little diagram, and then once you get the diagram, you've got the user relationship right. Everything's fine. Okay. So following on from that, there was a very important tutorial question, and I said last week it's one of the key or most crucial questions of the term. It's one thing that once you got your head around it, you'll be applying it through the rest of what we do this term. And that was one of them. There's a whole bunch of them, but one of them, the one we come across first is the vehicle, car, truck question, which is one of the tube questions last week. Okay, and you could declare a vehicle. Once you set up your classes, you could say vehicle, and you had a structure like this: public class vehicle, and you had public class car extends vehicle, and you had public class truck. They had three classes basically, and the car had, I think, number of passengers, and the truck had a carrying capacity. So how much could you carry in the back of the truck? So declaring objects of those types is pretty easy. Vehicle V1 equals new vehicle, no worries there. Car C1 equals new car, no worries there. Truck T1 equals new truck, no worries there. We're just treating them like individual classes there, so there's no worries. But you can also use the is-a relationship to help you store all of this data in an array or an array list or a linked list or any other data structure you like. I've just got a simple array here. So you declare an array of type the superclass, whatever the superclass is. And I've called it vehicles, equals new vehicle, and I could put a size there if I wanted to, 20 vehicles or whatever. Okay. So inside that array now, each row of the array can represent any one of these objects. It could be a vehicle, a car, or a truck. Anything that's in the hierarchy from vehicle on down. Okay, so if we had special types of car, for example, a sports car, if we added a sports car in there, and I recommend you do this for your own understanding. So add these in maybe for this week as extra homework. You could have a sports car and add a motorbike in. And that extends vehicle. And add maybe add different types of trucks in, container trucks, tanker trucks, I don't know, whatever. Different types of motorbikes, whatever you want to do. And the trick is once you've got these all in a hierarchy, a car, a truck, a sports car, a motorbike, or a vehicle can be stored in this array. So this one array can store any sort of data that's in the hierarchy. Okay, so you can do so.
Sorry, Mike. So the elements in the array, are they actually objects of the class that you assign? Like, say on your screen there, you've got vehicle 0 equals new vehicle.
Yep.
That is actually a vehicle object. And then the third one is actually a car object.
Exactly
it's not casting or...
No. It's actually a car object in the third location.
Okay, yep.
But
I was a bit confused.
yeah, but Java allows you because vehicle is a superclass. Java allows you to store any type of data that's a subclass of that, as well as vehicle in the array. So that's part of the magic of using arrays. That's what they're all about. Then you can store any type of vehicle in there. So for managers, for example, we could say an array list staff equals new. So we declare an array list of staff there called of type employee, which means we can store anything in the employee hierarchy in that array list. So we can store employees or managers, or if there was admin staff or programmers or anything like that in there, we could store anything in the array list. So we could go staff.add employee and whatever for the constructor we need to pass in. Staff.add new manager or whatever its constructor needs. And so at the first location in the staff array list, it'd be an employee. At the second location, it would be a manager. Okay, so it doesn't matter what data structure it is. They're all employees or something in the employee hierarchy. Okay, so this is where the power of arrays come in with inheritance and polymorphism. Okay. So when you come down here to declare vehicles, you could say vehicle 0 equals new vehicle for our vehicles array. I've given it size 20 there. Vehicle 1 equals new vehicle. So the first two items in the array happen to be vehicles. The next one's a car. The next one's a truck. And whatever we like. If we had sports cars and motorbikes in our hierarchy as well, we could say equals new sports car equals new motorbike, and so on. Okay, because they're all children of the vehicle class. They're all subclasses of the vehicle class. So any of those data types are allowed here. If you try to do this, that would of course be an error because the employee is not part of the vehicle hierarchy. Okay, so that would be an error. So it's only things that you're allowed to be in here with extends vehicle, or extends one of the subclasses of vehicle, car, truck. Then you could have different types of sports cars. You could have Italian sports car, extend sports car, and you could have US sports car or whatever. You could have electric car and fuel car and diesel car and all sorts of things if you wanted to. Okay, so they're all now part of the hierarchy. All of these things are all part of the vehicle hierarchy. So just to sort of reinforce this further, because this is really important stuff. This is the most important stuff, and we're going to be applying this throughout the rest of the term. So just to make sure you've really got your head around this, let's go through and work out the total number of passengers in all the vehicles, in all the cars. So only the cars in our array have got passengers. So what we need is a loop. It's less than the size of our array. We'll assume the array is full of data, so we don't have to check for nulls and things. So we'll go through every item in our array. So we'll go vehicle.length to give us the size of our array, k++. And we'll declare a total, int total 0. And now we're going to go through and work out, I'll make it a bit more meaningful, total passengers. Total passengers. So what we want to do here is the object car. And if yes, then add that passengers. So that's what we want to do inside our loop here. Okay. So you want to see what sort of data is in the array at that location. Is it a car? Is it a truck? Is it a sports car? Is it a motorbike? And then if it's a car, then we want to add the passengers to that car onto the total. We're just doing the cars for this one. Okay. So we won't worry about sports cars and stuff at this stage. We'll just assume there's just cars in there, just to keep it simple. Okay, so how do you determine what sort of object something is? That's where that instance of comes in. Remember instance of? That great little command I said was going to be so useful from now on. So that comes in, that's the key thing here. So you could say if vehicles K is an instance of car, then it's a car. Okay, and as soon as you know it's a car, it's safe to call the get passengers method. Okay, so we could say total equals total plus v equals k dot get passengers, or whatever the method was called. Okay. So we're calling the get passengers for that vehicle only if it's a car. Okay, so you're starting to see here what we can do with our array. We can store any type of data in it. And if it's a car, we can do special processing. If it's a truck, we can do special processing, and so on. So here we're adding up the total number of passengers for cars only. Okay, so that's where instance of comes in. We're checking, is there a relationship? Is that vehicle, is it a car?
Mike?
Yep.
So if you did a test of instance of vehicle, all of the elements in the array would come back true?
That's right. That's right. Yep, so they're all vehicles, but some of them are special types of vehicles.
So like if you had a particular type that you were just calling it a vehicle, you'd have to do something else.
You have to do something else, yes. You have to, if you want to be special, a special type of vehicle, it's got to be a special name, yeah. And of course, we can use our little shorthand here. Instead of going total equals total plus, we could use that little shorthand, a great little plus equals operator, to shorten our code down even further. And I could comment that line out then. Save yourself a bit of code, why not? Okay, so that gets you the total number of passengers. Now let's work out the average truck capacity. So we don't know what data is in our array. We just know our array is full of data. We don't know how many trucks there are. So again, we're going to try and work out what's a truck, create a total, and then keep a count of the number of trucks that we find and divide by that at the end. Okay. Are there any questions on the car so far? The total passengers? Is everyone okay with that? This is crucial stuff. Okay, for this term. No questions? Okay, let's do the average truck capacity. So we need an int, and I think truck capacity was a floating point number, a double. So let's go double total capacity 0.0, and we'll go int truck count 0. And I'm a bit I'm going to neaten up my code. I've got code issues where I've got to keep everything neat. Okay, so let's do a loop. The same sort of loop is up here. I'm just going to copy this code down here. Control C, copy it down, and change that to truck. And is the object a truck? If yes, then add the capacity onto the total. So I've just copied the above code and changed it to truck and truck and truck and capacity. And instead of the passengers, it's now the total capacity. And instead of the vehicles K, get passengers, it's get capacity. Or whatever you called it, whatever you call the method. Okay, so if it's a truck, we're going to add the capacity for that truck onto the total and also increment the count. We're keeping track of the number of trucks as we go as well. Okay, so this, every time we get a truck, we add one to the counter and also add its capacity on. And then to get the average, it's just double capacity equals 0.0. Set it to 0 to start with. And if, because you might have no trucks, and if truck count is greater than 0, you could say average capacity equals the total divided by the truck count. Okay, so with a little bit of code, we've got the average capacity for all trucks in our array. Okay, so imagine employing the same technique to person, employee, manager, CEO, admin, programmer. Imagine your company had a whole array of types of employees, and you wanted to work out the average salary for the programmers. Well, now you can do that really easily. If you want to give all the admin staff a pay rise of 10%, you could do that. It's just if the employee is an instance of admin, then give them a 10% pay rise. Call a method to give them a pay rise. Okay, so very powerful stuff, and we're going to be using it throughout the rest of the term. So instance of and arrays and data structures, array lists, and later on linked lists and queues and stacks, with declared with just the vehicle, the parent class, and then inside that data structure you can store anything that's in the hierarchy. So pretty powerful stuff. Are there any questions? Any issues? Okay. Anything anyone's not sure of? Do you want me to go over it again?
Good, thank you.
Okay, all good. Okay. So please keep this in mind for the rest of the term. This sort of stuff is very important. You're going to be doing that in your assignment 1, your assignment 2, and virtually most of the 2 questions from now on, you're going to be doing this sort of thing. Okay, so let's say you want to store any type of data in an array. So anything at all, dates, strings, employees, cars, trucks, vehicles, what would you declare the array to be? What type of data? What's the wildcard? What's the parent of all classes in Java?
Objects?
Oh, the object. Well done, Amy. Yes. So the object class. Okay. So if you want to declare an array of anything that you could store absolutely anything in, you could say object my array, my data, whatever you want to call it, equals new object. And in here we could say my array 0 equals new date. That's going to store the current date and time. And my array 1 equals new car, and pass through whatever the constructor needs to do its job, and so on. So we could just store anything we liked in that array, and we can use the instance of to work out what the data is. Is it a date? Is it a car? Is it a bird? Is it a plane? and take it from there. Okay, so powerful, powerful stuff. We're now getting into the real. This is where things get really useful. You can create data structures that contain anything, and you can tell what type of data everything is. So we're getting really into the power of inheritance and object-oriented programming. Okay, so please keep all these things in mind for the rest of the term. Thanks, Felix. I just saw Felix's comment. Thanks, Felix. Okay, so that's our recap, our recap and review. I just want to touch on the most important parts from last week. And did everyone pick up this sort of stuff from the tutorial? Did you understand that's where we're going? I thought the tutorial was pretty vague, and asking you to fill in the gaps, you don't really get to feel what the code's doing. But, so would you have been able to do this if I hadn't showed you? You've really got to be shown the first time anyway, really, to show the power of it, to show how it all works. But hopefully you can do it from now on. That's the hope. Keep that in mind, and we can do it from now on. But no worries, Damien. I've just seen Damien was late. That's all right, Damien. So we've just covered some really important stuff, Damien. So make sure you watch the first half of the first part that we just covered. Okay, very important stuff we just covered. Key for the rest of the term. Okay, so let's go on with polymorphism then. What's that all about? And it's following on from inheritance. There's a lot of very similar stuff coming up. We're just building on top of things we've already done. Okay, so we'll talk a little bit about abstract classes and abstract methods. We've got those coming up. What they mean. We've only got a few slides on them though, but there's a whole lot of stuff we could cover. Again, all of these topics are iceberg topics. We're just covering the very little top part. There's a whole lot of depth down below. And we'll come around again later on and talk about them again later. And we cover the next little bit of depth. And, there's a whole lot of hidden stuff down below for all of these topics. So we keep coming around and going over them again in a bit more detail, revealing more of the iceberg as we go. Okay, so, and then we'll talk about polymorphism. So an abstract class. So as you move up in the inheritance hierarchy, so let's do that. So you might have person, and then employee, and then types of employee. So you might have manager and admin and programmer and so on. And then you might have certain types of managers. There might be CEOs, and there might be who knows what. And there might be different types of programmers and different types of admin staff and different types of whoever you got as employees. So you got this whole hierarchy built up. And so as you go further up the hierarchy, things become more general. So a person is just anybody. They might have a name, address, an email address, a phone number. As you go down the hierarchy, things become more specific, more focused. So a CEO's a type of manager, and they might get the bonus a manager gets plus. They might have to play golf one day a week, and they might have to take their family to Hawaii for a week each year to go for a business conference, and who knows what they might have to do, the poor people. They get such a hard life. Okay, so as you move down the hierarchy, becoming more specific, more focused. As you go up the hierarchy, it's more general, more general purpose. Okay, so when you move up the inheritance hierarchy, the classes become more general and more abstract. So we're just talking about person in general. What's a person? And when we go down, we're talking about something that's more specific. What's a CEO? That's a lot more. That's a much narrower question than what's a person. Okay, so more general, more abstract as you go up the hierarchy. The ancestor class in the inheritance hierarchy becomes a basis for the other classes. And if you want to set them up as abstract classes, you can. So this top one here could be an abstract class if you want it to be. Okay, it could be just a normal class, or it could be an abstract class. We'll talk about this more in a second. An abstract class is a special class in Java that cannot be instantiated. We cannot create any objects of the class. Okay, so if we declare this one here as an abstract class, okay, then we can't do this. That would be an error because we're trying to create an object based on a class that we've declared as abstract. Okay, so that would be an error because it's abstract. So they don't sound very useful, do they? Why would you have an abstract class? And we'll look at some examples coming up. But the whole reason is that you want to create a template. So they can act as a template for all the other subclasses in the hierarchy. For example, you can say what methods the other classes need to provide. For example, get description. You might have a get description method here, a get description method here, a get description, get description, get description. But the person class might not have enough data to get a description for the employee yet, for the type of employee, because they're too high in the hierarchy. So you could mark that class as abstract and mark that method as an abstract method. In other words, any class that builds on me needs to provide the code for that method, is what you're basically saying. So another slide coming up here to show that. So person and employee and student, so two types of persons. And everyone might have a common name. There might be a whole bunch of other stuff as well. But for this example, we'll just say that name's the common field. There could be address, phone number, email, all sorts of things. But just for this simple example, we'll assume that name is the only common field we can find for employee and student. So we put the common fields up into the person class. And methods deal with those too. So the mutators and accessor methods and toString and all the other ones that we've been doing. Since we have to create objects of employee or student only, because we're going to declare person as abstract, so we don't have to create objects of person, we can make that person class an abstract class. Okay, so we're dealing with a case where person is just going to be a template. We never have to create person objects like that. We just need to create employees or students. So we can declare person as abstract, and that means we can set it up as a template class. So what's going to follow down below. Okay. So how does it work? Let's have a look. Okay, so we can tell this class is abstract because there's the abstract keyword there in the declaration. Public abstract class person. That gives it away straight away. It's an abstract class. And also this one has an abstract method. So public abstract string get description, semicolon. So that's ending the declaration. And by saying it's abstract, it's saying I can't provide, you're basically saying to Java, I can't provide the details for this method yet, but anything that extends me will have to provide that method. So you're setting it up like a template. Anything that's coming later is going to provide this method. Okay. The person class has got a name. So it's got a constructor, it's got a get name, it would have a set name as well. It would have a toString, it would have an equals, it would have all things we looked at last week. We're just trying to keep it simple here, just a few methods. Okay, and get description is abstract method. And of course that could go up here or could go down the bottom or anywhere in here, as long as it's not inside another method, of course. But you put that line of code anywhere. Generally what I do is I put the abstract methods at the top. So that if anyone's looking at my code, they can say, there's 4 abstract methods there. I need to provide those details in my class. Okay, so put them up the top, it's not a bad thing to do. Okay, in person class, get description methods abstract. It does not have any implementation code. There's no code in the method. There's no opening and curly brackets. Okay, so no opening curly brackets. It's just a semicolon at the end. And we don't have semicolons here at the end of our method implementation. So this is a special way of writing a method that's abstract. So no curly brackets and just a semicolon at the end. Abstract methods act as placeholders for methods expected to be implemented by subclasses. Okay, so templates, placeholders. You can ensuring that everything that's in the hierarchy has a get description method if it extends the person class. Okay, if it doesn't extend if it extends the person class and doesn't have a get description method, then it can't be an instantiated class. So any class having one or more abstract methods must be declared as an abstract class. So if you've got an abstract method, that must be abstract. Okay, so if you've got one or more abstract methods, you must be public abstract class at the top. A class can be declared as abstract, even if it does not contain any abstract methods. So if we took that line of code out there and just said abstract class, that's still fine. It just means nobody can create an object of type person. For some reason, you've set it up that way. It's just like a little template class at the top that everybody can use. It's in the hierarchy. Okay, so all the common data, all the common functionality goes up there. Name, address, phone number, all that sort of stuff. And then when you come to add classes to the hierarchy, for example, student, public class student extends person, so we're extending the abstract class. Then we're adding the data that the student knows about or the student needs, like major and GPA and whatever you might need. Okay, and then you've got a constructor, string name, string major. We pass the name up to the parent class, which is person, super name, and it can do the initialization for its own data. And then we just say this.major equals major to initialize this class field. This.major is that one. And major without the this in front is this local one. Okay, and then we can say get description, and description is a student majoring in whatever the major was that they passed through here. So a student majoring in IT or student majoring in allied health or whatever. Okay, so that's just a simple class again. It's just keeping it as short and simple as possible to not make it huge and multiple slides. But that's the basics of how it works. So extends person, and then you take in all the data to the constructor to create any type of person, a student, as well as anything upper in the hierarchy. And then you pass through the details to the parent class, super followed by name in this case. Okay. Now this class can be instantiated. Student can be instantiated because we've provided the details for the get description method. We've provided the implementation. There's the code for the method. Okay, so this class here is it's what's called a concrete class. And be instantiated. That's quite okay. Declaring a student called Fred and passing the name and their major across the student constructor, that's fine. We can do that because student is a concrete class. It can be instantiated. Okay. Any of the methods that were abstract in the parent class have been implemented, and there's no abstract methods here, and the class isn't declared as abstract. So that's what's called a concrete class. We can create objects of that class. Let's look at a little bit more. So this is that was student. Let's look at employee. So we'll sort of merge a bit of our code from last week in as well. So public class employee extends person. We've got the salary and the hire day. And the constructor takes all the details for an employee. So name, salary, and the year, month, and day as integers. And we pass the name across the superclass. Store the salary in our local salary class instance field. And construct a hire day from the year, month, and day like we did last week. Get salary, get hire day, get description. Here's our description. And the description is an employee with a salary of whatever salary is with 2 decimal places. Okay, so that's mostly our code from last week, just with get description added in. And so this class doesn't have any abstract methods. It extends person, but it provides the full implementation for the get description method. And there's no abstract here. So this is also a concrete class. We can create objects based on it. If there was abstract here, or if there's any abstract methods anywhere inside the class, or if we didn't provide an implementation for get description, this would still be an abstract class and we couldn't create objects based on it. Okay, so. So if a class has no abstract methods and it's not declared to be abstract, and it provides full implementation for any methods that were declared abstract higher up in the hierarchy. In other words, if it provides the implementation for any methods that were declared abstract, and it is a concrete class. Okay, so no longer an abstract class. Okay, so concrete and abstract. So why would you use abstract classes? They seem a bit strange, don't they? Especially if you want to provide a template for what's going to come lower down in your hierarchy. For example, a computer game. Let's look at computer games. Everybody loves games. You might have a public class. Public. Abstract class. Game object. And get hit points. So this might be for game objects in your game world, and you might be getting the hit points. You might have abstract void, do damage. You might have public, abstract, Boolean is immune to damage, and a whole lot of other things as well. So you could have a whole bunch of methods here, which they're all declared abstract up here. So anything that extends game object needs to provide the implementations for them. For example, a player. Human player extends game object. And they would provide their own version of the get hit points. Humans might have 100 hit points of damage at the start. They might do 5 hit points of damage when they hit someone, and they might be immune to damage only sometimes if they pick up the cloak of invulnerability or whatever. Then they might be immune for a short period of time, 5 seconds, 10 seconds, or a minute, or whatever you want. Okay, so that's the way you can chain all these things together to create really complex worlds. For example, in games.
Hey, Michael, Jared just asked a question in chat.
Okay. What's the point of using abstract? Couldn't you just use a non-abstract class? So could you? Yes, you could. You could just use a non. So I'll put that in the chat window, in the window here. So maybe I missed the part, but what's the point of using an abstract class? Couldn't you just use a non-abstract class as a template as well? And you could, yes. Okay, but if I use an abstract, if this was an abstract game object, then I would have to provide implementations for all of these methods, and I might not have the information yet. It might depend on the type of object. You might have another object called monster. Monster, flame monster. Okay, and they might have their own attributes. And then you might have another type of monster called the boss monster, which might be an end of level, something like that. So you might not have these informations until later on when you're actually setting up the objects. So in that sort of situation, human player, in that type of situation, it wouldn't make sense to have game object as abstract. Abstract. But if you know all the information at the start, then you could make it a non-abstract class if you wanted to. Okay. And don't forget if you create a class as the yeah, I mean you could fill in methods here as well and just override them down here, and that would still work. So you could provide a basic implementation to get hit points up here where you don't know what the data is. Return 0, return -1, whatever. And then down here, you could do an override and return the right values for humans, and then an override for flame monster. So yes, you could do the templates with normal classes, but then you might find yourself using override everywhere, which isn't a bad thing anyway. So yeah, there's many ways to do. There's many ways to do stuff, and many roads lead to Rome. So yes, you could. A good question. Thanks, Jared. And then there's a bit of a tester class here. Set up an array of people or array of person. People 0 equals new employee. People 1 equals new student. And then we can loop through and display their names and descriptions. So for the first one, it will say employee. It'll say an employee with a salary of 50,000. And the second will say a student with a major of computer science. Okay, so which get description method gets called depends on the type of data. Is it a student or is it an employee? They're all people or person. They're all type person, but they're down here, they're more granular. Is that all okay? So abstract classes, you might use them a lot. Some people love them. Other people just prefer to provide basic implementations and then overrides down here. However you want to do it, there's many ways to do stuff. Any questions on abstract before we move on? Anything you want to talk about? Polymorphism. Polymorphism means many forms. So we've talked about overloading and polymorphism a little bit in the past. So overloading, they're similar sort of topics, overloading and polymorphism. Usually overloading is used for methods and polymorphism is used for data. Usually. Okay, but we should use polymorphism, that one term, to apply to both. Okay, so what's overloading in methods? Remember last week we had multiple constructors for manager, and we had one that took a name, another one that took a name and a bonus, and we had the same sort of thing for employees, and we could create managers in different ways depending. We had a default constructor as well. We didn't know anything about the manager. So we've got 3 methods all called manager. They're constructors, but they're still methods. We've got 3 methods called manager, and which one gets invoked depends on how you call it. So here's the default constructor one. Okay, there's one that takes just a name, and there's one that takes a name and a bonus. So we've got 3 methods all with the same name, and Java knows which one to invoke based on what parameters are passed. That's overloading. That's all overloading is. It just says you're thinking up multiple names, so really what is the same method? Okay, let's look a bit further. When you look at array lists, if you want to add strings to an array list or add a string to an array list, you could just say strings add Mike. Let's add that string. Okay, so it's the add method. We did a little bit of GUI programming in a prior course. We actually did 2 weeks for the students that came through with me. And we'll do 2 weeks, next week and the week after, are both GUI programming weeks. So we'll do a refresher and then move on as well. Okay, and when you're doing GUI programming, if you want to add a label to the user interface, it's just add my label. Okay, and if you want to add a button to a panel, it's my panel. Add my button. So we've got add. And if you want to add a menu to a menu item or add a menu to a menu bar to an application, it's just add menu bar. So we've got four add methods being called here, all with the same name. And which one gets called depends on what parameters you pass. And also the context. Is that an array list? Is that a panel? Is that nothing? In other words, what is it if it's nothing? And if you do that in the constructor, it's adding it to the JFrame. Okay, so there's thousands of add methods in Java, and which one gets called depends on what parameters you pass through and what's involved in the call. What's the context over here? So it all depends on context and parameters. So multiple methods, same name. Which one gets called depends on the context and the parameters. And that's all overloading is. Polymorphism overloading, many forms of the same method. And you might be thinking, well, whoopee-doo, what does that matter? Okay, and it actually matters a lot, because in the old days, let's put the waves on the screen so we can go back to the old days. In the old days, okay, you couldn't write code like this. Okay, you'd have to say add string to array list, add label to frame, and add button to panel, and add menu bar. So what sort of code would you rather write? Code where you just have to remember one method name, add, or code where you have to remember thousands of different add methods? Okay, there's no contest, is there? Simplicity wins all the time. This is a horrible, horrible way to write code. Okay, and I am skewing things a lot here. I am skewing things a lot. You could get around a lot of this stuff by writing your code right, but I'm just exaggerating it just to show you how bad things could have been. Okay, so I've got 4 methods there, all with different names, or we can have one method that we have to remember, add. I know which way I'd rather write code. The bad old days. And it was a days. Having to remember 4,000 methods to do add stuff, that was horrible days. Okay, so hopefully I've helped you understand what overloading is. Let's look at polymorphism, and we've been talking about that already. So up here. Morphism, here we go. Okay, so we've got an array of vehicle here, an array of vehicle class, but vehicle O is a vehicle, vehicle 1 is a vehicle, vehicle 2 is a car, vehicle 3 is a truck. Okay, so we've got multiple types of data stored in one array of vehicle, and that's what polymorphism is. Okay, so it just means many forms. As long as whatever you put over here is in the class hierarchy at vehicle level or lower, you can make an object of that and store it in a vehicle array. Okay, many forms. And you can use the is a relationship. So is if vehicle whatever is an instance of truck. You can do whatever you like with that truck. Okay, you know it's a truck. Now, I did leave out a little bit of code earlier, and we'll cover it now. I did leave out a little bit of code just to simplify things up here a little bit. And Java still does get twitchy about things. Okay. Even though it's vehicle and car and truck are all part of the hierarchy, Java still does get a little bit twitchy. So you can't actually say vehicles k.get passengers. Okay. So I did simplify things slowly at the start. You need to do a little bit of typecasting. Okay. It's a little bit nasty. So you need to convert that to a car, because you know it's a car. You've checked if it's a car, so that's a safe typecast. And then you need to put brackets around all that. Okay, so it's a little bit of nasty code there, just to keep Java happy, to reassure Java you haven't gone insane and you know what you're doing, basically. So again, that needs to apply down here. So I need to just copy that typecast down there. So I didn't put that in early because I didn't want to cloud the situation and make it unnecessarily complex. Okay, but for that to be valid Java code, even though car is part of the vehicle hierarchy, you still need to tell Java that it is a car you want it to be referring to, and then you can get passages for the car. Same for truck down here. So you can say truck in round brackets. Okay, and then to keep Java happy, you need to put an extra round brackets around that up to the dot. And Java's happy then. So that little bit of typecasting was needed as well. Typecast to car to keep Java happy. And down here we typecast the truck to keep Java happy. We know it's a truck because we checked the instance off, so we know everything's fine, but just to keep Java happy, just need to do that extra step. Okay. And that's basically it. So down here you could say, we know it's a truck, so we could say truck I'll make that K just so it's not question marks. So we're in a loop here. So we found out it's a truck, so we can say, give us a truck, T1, and we're going to use that reference out of the array, which is a truck. So again, we're just reassuring Java we know what we're doing. And once we've done that, we can say total equals total plus equals. This is the same sort of code we had before, but instead of doing it all in one line, instead of doing it like this, we're going to use the extra round brackets. You can split it down to 2 lines. Same thing. We're getting the reference to the truck out of the array, and we're using that reference to get the capacity of that truck. Okay, so both those ways work fine. I tend to prefer this way because it's less code, less lines of code. Some people like that way to start off with and then maybe change later. Whatever you want to do is fine. The trick is to get the vehicle out of the array and typecast it to truck, and then you're safe to use truck methods with it. Any questions on that? Anybody confused or not sure? I know a lot of this stuff's sort of brand new and different to what you've maybe learned already. But, we're just peeling back the layers of an onion. There's this great big onion or an iceberg, just slowly exposing more layers.
So if you were using an advanced for loop, would you still have to cast the object?
Yep, let's do that. For vehicle V in the vehicles array. If V is instance of, it's basically the same code, but instead of the array reference, you're going to be using the V there, and it would be V there or V there. Okay, so for each vehicle V in the vehicles array, is that vehicle V an instance of truck? If it is, so we can call the truck methods after we do a bit of typecasting. Good question, Wayne. That's a good question. And just to make it so I'm showing everything, I'll put in an extra code up here as well. Okay, so that's an old counter-controlled for loop, and this is the compact for loop or the for each loop. And that would be, yeah, total capacity. I've got to fix some variable names. It doesn't really matter. Total capacity. I've got to add one to truck count. It doesn't matter. I'm just showing you how it works. Okay, so don't forget that typecasting. If you don't do it, Java will give you a compilation error saying an object of type vehicle or an object of this type cannot call the get capacity method or something like that. It'll say you can't call that method. So as soon as you start seeing that sort of stuff and you know it's a truck, then just put that typecasting in and you're good to go. Right, everyone okay? We'll move on. So polymorphism, an object can refer to multiple actual types. It's called polymorphism. Automatically selecting the appropriate method at runtime is called dynamic binding. Whoa, static binding, dynamic binding. Oh my goodness. It's so complicated. No, not really. Static binding. Java can work out which method to call. Compile time. Dynamic binding. Java can work out which method to call at runtime. When your program is running and you've got the data stored in the array, then Java can finally work out what method needs to be called. Okay. Or if it can work it out at compile time, it's called static binding. So the earlier Java can work it out, the better for Java, but it can't work out everything at compile time. So some things it needs to do dynamic binding. For example, if we were loading this array from a database or from a file, Java can't possibly know what's going to be at location 4 in the array at compile time. It's only when you're running the program that the data comes into the array. Okay. So if Java can do it at compile time, it will. It'll link the methods up, but otherwise it's going to be linked up at runtime. If we load that array from file or from database or from somewhere else, user input, then Java can't possibly know what data is going to be in the array at compile time. So it works out what objects are and what things are at runtime. That's the only time it can do it. That's static binding and late binding. Actually selecting the appropriate method at runtime is called dynamic binding. You can only work it out at runtime. If a method is private, static, final, or a constructor, then the compiler knows exactly which method to call, and that's known as static binding. Or if the data type is known at compile time, if the exact data type is known at compile time, you can also use static binding. Otherwise, the method is to be called depends on the actual type of the type of data or the implicit parameter, and then dynamic binding is used at runtime. So here we've got a manager, create a manager object and set its bonus value. So manager boss equals new manager, Carl Cracker, 8,000, 19, 27, 12, 20, and then set bonus, boss.set bonus. So these sorts of things we're doing last week. And then we've got an array of employees, employees staff equals new employees 3. So we're going to store 3 employees in our array or up to 3 employees. Staff 0 equals boss, staff 1 equals new employee, staff 2 equals new employee. So we're storing all the data in the array of employee, but because manager is a subclass of employee, we can also store managers there as well, just like we did with vehicles, cars, and trucks. Same thing. Okay. So down here, when we're looping through all employees, for each employee E in the staff array, that's our staff array. For each employee E in the staff array, we're going to get their name and we're going to get their salary. Okay. Now for the employees, for these two, it's going to call the employee version of the get salary method. Okay. But because we've got a boss here, which is a manager, really, we're going to call the manager version of the get salary method, which gets the salary plus the bonus. Okay. So we should see it should be 8,000 plus 5,000. So it should be 13,000 for the manager and just 50,000 and 40,000 for the employees. So again, that's polymorphism in action. It's just the parent type of data is used to declare the array, the superclass, and then anything in the hierarchy from that point and lower can be stored in the array. And Java works out the plumbing for you. So which get salary method is called is determined at runtime. So that would be dynamic binding. Okay. Especially if all this data was coming from file or database or user input, then it would definitely be dynamic binding. So the get salary method for staff 1 and staff 2 returns the salary, whereas get salary for staff 0, the boss, returns the sum of the salary plus the bonus because it calls their special get salary method. So the e.get salary picks out the correct get salary method based on the type of data. If variable e is referring to an employee, then the employee's get salary method is called. Otherwise, if variable e is referring to a manager, then the manager's get salary method is called, which returns the salary plus the bonus. It's what we've already done really with trucks and cars and things already. Same thing. So the variable declared type of E is employee, but the actual type of the object to which variable E refers can be either employee or manager. The fact that variable E can refer to multiple actual types is called polymorphism, many forms. E can be an employee or a manager, or if there's other things in the hierarchy, it could be those as well. So many forms, that's all it means. Sounds really scary, but it's really quite simple when you just get your head around it. It's just many forms of the data that can be stored in an array. Just think of it that way. And like we did here with vehicles, cars, trucks. We might have a quick 5-minute break if you like. So have a 5-minute break. So it's 10:09 now, so we'll come back about 10:15. Only got a few slides to go. We've really covered far more than we needed to this lecture already. And then think about if you've got any questions, like from last week's tutor or last week's class. I've had a couple of questions emailed to me. So if you've got any questions, please, we can talk about those as well. We've got plenty of time. Okay, so have a 5-minute break. See you back about 10:15. Okay, we're back again. We'll resume share. Back again. Can everyone hear me okay? Okay, thanks, Wayne. Thanks, Damien. Okay, so it's all comes down to, if you can't determine what type of data is it, compile time. It's got to be determined at runtime. For example, what's in an array? What's going to be stored in an array at runtime? Java can't know at compile time. And you've got dynamic binding. Otherwise, if it can determine it at runtime, at compile time, it does it, and that's static binding. And polymorphism, just many forms. You can have many forms of data stored, for example, in an array. An array of vehicle can store anything that's in the hierarchy from that point downwards. Very powerful stuff, this. So there's our employee class, very similar to what we had last week. They keep adding methods, removing methods. The equals method we did last week's gone. So I recommend you build up your own in your own folder and keep adding to it as we go. Probably be returning to this a lot during term. Manager as well is missing the equals method from last week, but it's basically the same code. Okay, and then manager test. So manager boss equals manager. So here we're creating a manager separately. Okay, but you don't need to. We could create them here as well. We could say staff 0 equals new manager, and then all these parameters. So new manager, and then staff 0 dot set bonus to 5,000. That would be quite okay as well. So you can do it separately if you like, or we can do it all in the array. It's either way works fine. So I'll just show you the array way if you want to see that. So slide 17. Staff 0 equals new manager. Carl Cracker. $80,000. His salary went up. It was only 8,000 on the other slide. 12, 15. That's creating the manager in the array. And then you can just say staff 0 dot set bonus 5,000. Okay. And if Java's ever not happy with that sort of thing, just do a bit of typecasting. So it could be so to do the typecasting, you put the manager in front. Okay. But Java's still not happy with that. You've got to put round brackets around the whole lot. Just before the dot and just before the first round bracket. So round brackets around all that you have to put as well. So if Java's not happy with that, just do a bit of typecasting and away you go. And so now we've got all the managers and employees stored in the array, and that's our for each loop that we just looked at on the prior slide. If you want to use an array list instead, so array list of employee. And I do encourage you to use array lists. They're very good. They can dynamically expand as much data as you need to store. So emps equals stuff. So just to add an object to the array list, it's .add. I might call it array list just so I can clarify between the two. Staff array list .add new employee. Thank you. So that creates our employee. And then we want to add them to our array list. So we're going to add close round bracket and add a semicolon. So we're creating an employee and we're adding them straight to the array list. So what sort of data is that called? There's a special name for it. We're not naming the data. So what's the special name? It begins with an A. And you remember that from the prior course? It's anonymous data. Okay. Up here when we created a manager. We gave the manager a name, M1. It's not much of a name, but it's a name. Okay, so they got a variable name. So that's not anonymous data. But here we're just creating it and saying we don't care what we don't want to ever give it a name. Just add it to the array list. Okay, but you can do the same thing down here if you wanted to. You just say stuff. Let's do that for manager. So new manager. So we'll create a manager and we'll add them to the array list. That's how we did it for the array. This is how we do it for the array list. So I'm commenting out that line. So adding M1 to the array list. Okay, that's fine. Or if you want to do it using array list notation, you can do it as well. For example, down here, we can add M1. And we want that one, really. I want to use that typecast one. It's always better to do the typecasting just to make Java, keep Java happy. So we want to get the one we just added, okay, which we know is the first one. So we could say get 0 if we wanted, but if we didn't know what number we just added, what number, because it was the first one added to the array list. If we didn't know, we could say array list dot get size. This one. It gets that that employee at that location. So use the .get and .add for array lists. So we're getting the one we just added, and we're going to set their bonus. Okay, so this might be a little bit cleaner for for when using array lists. So create the manager as a separate object and then add them to the array list. It just saves you doing this sort of stuff where you're getting the last one. So size -1 to get the last one, because indexes go from 0 to size -1, and then set bonus, whatever. And you might also have to do some typecasting around that. In fact, I think you probably would. So you have to go round bracket and put a manager round brackets at the front. So that gets pretty unwieldy pretty fast, doesn't it, when you use array list notation? So that might be a better way to go. So if you're doing, if you got, for example, in assignment 2 last year for last course, we had different types of pizzas, and we're adding those into an array list. That would probably be the easy way to go if you've got multiple types of data. Create the manager, add them in. Create the employee, add them in. Create the CEO, set their bonus, set their salary, set this, set that, set their golf time, add them into the array list. Just so you're doing all this sort of stuff. So typecasting and -1s and stuff. The output would be that, just like we saw. So the is a rule. Every object of the subclass is an object of the superclass. So manager is an employee. Don't forget that. That's it all comes down to is a. Is a. Manager is a employee. Okay, so an array of employees can include managers and employees and anything else that's in the hierarchy from that point down. But employee is not. Okay, so not all employees are managers. All managers are employees, but not all employees are managers. So you couldn't declare an array of managers. Store here, you could create an array of employee and store managers in it. That's perfectly okay. It all depends on which way the user goes. I still find it useful to draw a diagram because you can end up with hierarchies. You've got lots of branches out the side and lots of depth. End up with huge hierarchies. Draw the hierarchy or keep a diagram handy, and then just get in the hierarchy and you can see what you can do straight away. Everything makes sense. Okay, because you might not be creating an array at the superclass level. You might pick a point halfway down the hierarchy and create an array of those objects. Maybe just the monsters in your game. Okay, and you're going to loop through all the monsters and apply all the damage they do. Okay, or who knows? Okay, so it doesn't have to be the parent object. It could be, or parent class. It could be something anywhere in the array in the hierarchy. You can create an array of that, and then it's just those things from there down that you can include in the array. So what could we, if this is our hierarchy, what could we store in managers? It's really just managers or CEOs. Okay, so we're creating the array at this level. So we just store managers or CEOs in there. We couldn't store employees. Okay, because they're up the hierarchy. If we create an array of employee, I should probably down a level. If we create an array of person, an array of person could store anything. So on. Okay, so that's how you do it. You can create the hierarchy at the parent class, superclass level, parent of all classes, or you can pick a point anywhere in the array and create an array of those objects if you need to. It just depends on what you're trying to do. Okay. You might need to work out the costs of all managers in the company. How much are they costing the company each year for all these useless managers that are playing golf all day? And so you can work out the total salary for them by creating an array of those objects, loading them from the database, and whatever. Okay, it's all good. Any questions? Some activities. So has anyone got any questions from last week's tute? Again, if you missed the first half hour or so of this class, or a bit more half hour, we covered a lot of this last week's tute in this week's lecture. So watch that as well. Has anyone got any questions from last week's tute that they're worried about, or anything they're worried about? Otherwise, we can go on and work on these exercises if you like.
There's a question in the chat.
Okay, yep. Yeah, so, and we did talk about this, so question there. So we did actually talk about this. So polymorphism and method overloading, they're similar concepts. So they basically mean many forms. Okay, overloading is usually to do with methods, and polymorphism is usually when you're talking about data. In fact, I'll scroll back up and I'll show you. You ready? Maybe I didn't write it down. Anyway, it doesn't matter. So polymorphism is usually when you talk about data, like we just saw with person, employee, manager, and so on, and vehicles, cars, trucks, many forms of data. You can say everything's an employee in the array, and then store managers, CEOs, and admin staff, and whatever you need. So that's many forms there. And then method overloading is when you've got things like the add method we talked about up here. So to add a string to an array list, it's add. To add a label to the user interface, it's add. To add a button to a panel, it's add. Add a menu bar to the user interface, it's just add. So it's all the add method. And which ones, we've got multiple methods with the same name, and which add method gets called depending on the context and the parameters. So again, that's still polymorphism, but usually for methods, they call it overloading. Okay.
Thank you.
Okay, still just means many forms, many methods that do different jobs based on context and parameters, or many forms of data that can work in together and be stored in the one data structure. So before if we didn't have the object class, and if we didn't have polymorphism, and really the object class allowing us to store anything in the object array, an array of objects, is really a form of polymorphism, because object is a parent of all classes in Java. So if we didn't have polymorphism, then we couldn't create an array of whatever and store managers, employees, things in there without polymorphism. So it's really, really important topic. We'd have to create an array of managers and load all them from the database, and then create an array of employees and load all them from the database, and then an array of admin staff and load all them, and have all these different arrays depending on how many jobs we had. And if there was 50 jobs in the company, 50 job titles in the company, we'd have to have 50 arrays. Hell, what a nightmare that is. When you want to loop through and add up the total salaries, you'll loop through 50 arrays. Much easier if you can just use one array. Okay, so that's where it all becomes really beautiful. Okay, let's have a look at some exercises. Define an employee class, specify at least 2 instance variables with suitable data types. Make sure the employee class has an abstract method for returning the total earnings. Okay, so let's do that. And I'm just going to provide a brief skeleton here. Okay, so we've got some data. What data did it say? 2 instance variables with suitable data types. It doesn't say what they are. Right, so we'll have a private string name and a salary. Why not? They're the 2 easy ones. I'm not going to worry about curly brackets. I'm not going to worry about filling in a lot of the code. This is just a bare template So you can follow along at home and fill in flash out the details. So we've done the first part, 2 instance variables. Make sure the employee class has an abstract method. Let's do that. And it says total earnings. So get earnings. Public. Double. It's probably going to return a double since it's earnings. Get earnings. Doesn't say what the method's called. Let's call it get earnings. And it says it's got to be an abstract method. Okay, so abstract means you've got to put an abstract here. Public abstract double. And don't forget your semicolons. That's an error everybody makes. So leave on the semicolon. And no opening and curly braces either. Don't do this. No. It's no longer abstract. You provided an implementation. If there's curly brackets there, that means the method's implemented. Okay, so it can't be abstract. So semicolon. As soon as you put abstract here, your class has got to be declared as abstract. So you've got to put public abstract class up here. Okay, I'll just scooch this over. Define 2 subclasses of employee. So you'd have your accessors and your mutators and your toString and your equals. Okay, just like baking a cake, just like we always do for all of our classes. And of course, your constructors. Don't forget your constructors. Okay, but there's one abstract method there. So I would normally put that right at the very top of my class. Just make it really clear there's an abstract method. Okay. Even though the abstract does as well, sort of tell you that, but okay. Define 2 subclasses of employee. Let's do that. And it doesn't say whether they're abstract or not, so we'll just make them non-abstract. We'll make them concrete classes. Class manager, extends employee, and another one called programmer. 2 classes that extend employee. Okay. So we've done that. Discuss the issues in parameterized constructors of those subclasses. Provide concrete methods by providing implementation codes for the above abstract method. Okay, so providing implementation just means you're going to write the method for each class. Fill in the details within the curly brackets. So again, we could provide complete classes if we want to. So let's have a bonus. Managers have got bonus, public, private, private, double, bonus, and so on. And a programmer, what could a programmer have that's unique to them? It might not be money. It might be because they work such long hours, and and when deadlines come, they're always working till midnight and eating pizza and drinking too much Coke and stuff and listening to too much loud music. So that's how the stereotype goes. We could give them an extra week's holiday year or extra 2 weeks holiday. How would that be? So private int extra holiday. Just for fun. It's our own class. We can do whatever we like. Okay, so the manager's got their bonus, and the programmer might get extra time off for working so many late nights and weekends. Okay, so discuss your issues, parameterized constructors in those subclasses. Discuss your issues and provide concrete methods by providing the implementation codes. Okay, so we had an extra abstract method, get earnings. So let's move that down here into the, and again, you would have this class would also have its constructors and stuff. I'll leave you to fill in those details. And so with this class, every class you create, every instance class you create's got those things. And even if it's abstract, if you can provide any of those, provide them as well, because you've got name and salary to provide them for. So let's talk about this part first. Provide concrete. Okay, concrete. So we'll take that and we'll move it down here. And we take off the abstract. And so we can say return. We can call a superclass dot. Well, actually, we can't call a superclass methods for get earnings because it's abstract. So we can't call that one. So what we need to do is call the accessor method to get us a salary. Okay, so super dot get salary, assuming that's there already, assuming you've done that, plus bonus. Okay, so we can't call get earnings in the parent class because it's abstract. Doesn't exist. Just a header. That's all it is. Okay, so we're going to call get salary to get us a salary. And down here for the programmer, they just get the same old salary. So we'll just say get salary. They don't get a bonus or anything. It's just an extra week holiday or 2 weeks holiday a year, depending on how their crunch time goes. Sound good? Any questions so far? Okay. Discuss the issues in parameterized constructors of those subclasses. The issues. Okay, to explore the issues, let's go back to the very first examples we looked at in today's class with the abstract class person. Okay, now we cannot create objects of this class because it's abstract. Okay, there's an abstract class here and there's an abstract method. There's a method that's not been completed or implemented yet. So we cannot create objects of person. If we try and do something like this, Java will give us a compilation error. Okay, and there it is there. So, and it's saying person is abstract and cannot be instantiated. In other words, you cannot create objects of that class. Okay, so so you might be thinking, well, person's a template. It's useful for maybe being a template, but can you do anything else with it? And in Java, there are things you can still do with this class. Okay, so let's have a look at the student class. And down in the student class, we've got a major, and that extends person, sorry. Student class extends person, so it's a child of person. And we've got an extra field called major, and we've got a parameterized constructor that takes a name and a major, and we're passing the name up to the superclass. So in other words, we're saying to the person class, you deal with a name. You know about name. There's a name there. So you're responsible for that field. So I'll pass that up to you to take care of and store, and I'll just take care of the major. So this dot major is our class field major, and major without anything in front, without this in front, is our local variable major that gets passed in. Okay, and then to get description, a student majoring in the major, that's our major field that we've got up here. So the value of that gets displayed or returned. Okay, so even though person is an abstract class and we can't invoke objects of that class, we can still invoke the constructors. And here we're invoking the superclass parameterized constructor that takes just a name. So this is perfectly okay. Even though student is abstract, even though the parent class is abstract, Java still allows you to do this. Okay, so let's see that in action. So let's declare a student equals new student. Okay, and the constructor requires a name followed by, let's have a look, requires a name followed by a major. And Frankie's majoring in IT. Okay, and that should be fine. So we'll take out this one because we know this one's invalid. We can't create person objects, but we can create students, and that's all fine. Okay, so Java allows us to create a student object because student is a concrete class. It can be instantiated. It's not abstract. There's no abstract methods in here. Okay, so and we can call a superclass constructor even though it's a superclass constructor of an abstract class. Java allows you to do that because of the inheritance hierarchy. So it gives you like a free pass to do it because student is a special class. It extends person. Okay, so now we can say stuff like system.out.println s1.getName. Okay, and that should be a dot. So S1 is a student, and we're calling the getName method, which doesn't exist in here. The student class doesn't know anything about name. Okay, it's the parent class again. So we're calling that getName method, which returns the name. So again, person is an abstract class. It cannot be instantiated, but we can invoke the constructors, and we can invoke any other methods that might be in here, the accessors, the mutators, any other methods that are in here, we can call from child classes, okay, or children of children, okay. So if student extended person and PhD student extended student, we could still call super name from the PhD class, even though it's a child of student, which is a child of person. Okay, so that would still be okay. So s1.getName's fine, plus space, plus s1 dot, let's get the description, which is this method here. Okay, and that should be fine. So s1 get name means get me the name. Java goes back up the hierarchy till it finds, to look for a get name method. There's none here. Goes back up to the person class. There it is. So it invokes that one. When we say s1.getDescription, Java goes back to the hierarchy. So it starts off with student, and there's our getDescription method. So it doesn't need to look any further. It's found it straight away. So if we run that code now, we should see Frankie is a student majoring in IT. So we should see Frankie is a student majoring in IT. Control 1, Control 2, and there it is. Frankie's a student majoring in IT. Okay, so that's all working great. Okay, so just to recap, we couldn't do we couldn't instantiate person. Cannot instantiate or create objects for the class, which just means create objects for the class. Objects of the class, because person is abstract. So that's why we can't create that person there. Student's fine. So this is perfectly okay. Okay, and if we go back up, oops, if we go back up the up here, so there is a rule. There are some rules to do with this, and the main rule you got to remember is that it's got to be the first Java line of code, the first Java statement inside your constructor. So if you want to call a superclass constructor, it must be the first line of code. You can have comments before it, that's okay, but it must be the first line of code. Okay, and that applies whether the parent class is abstract or not. It doesn't matter. Okay, it's got to be the first line of code to call to the superclass constructor. And our person class is abstract, so that's fine. Okay, so even though it's abstract, the constructor is still usable and the get name is still usable. And if there was mutators and equals and other methods in here, we could still invoke those as well. Okay, just because it's abstract doesn't mean we can't use it. And it's one of the things that Java allows us to do. Okay, and we can create students, or if we had subclasses of student like PhD, we could create PhDs and all sorts of things. So anyway, I'll leave that to you to explore further. The trick is to explore. So write lots of code, explore these sorts of concepts a lot before the next class, and pretty soon you'll become comfortable with them. Okay. Any questions before we go? So if you missed the first part of this class, please go back and watch it on YouTube. Okay, thanks, Lewis. Please go back and watch it on YouTube, because I really talked about how important that the vehicles, cars, trucks stuff was. And we went over a lot of things to do with the user relationship and how to tell what type of data stuff is. And in here we worked out how to work out the total number of passengers in cars by checking what each object in the array was. Is it a car? Is it a truck? Is it whatever? Is it a bird? Is it a plane? And if it was a car, then we could keep track of the number of passengers for all the cars and total them up. Last week's lessons on YouTube. This one will be too later today, hopefully, if all goes well. Yeah, they're all on YouTube. Yeah. And in here for the truck, if it's an instance of truck, then we could get the capacity for the truck, add one to the number of trucks, and if the number of trucks is greater than 0, we could divide the capacity by the count. I get the average capacity. So this is where the power of polymorphism and this, what we're doing is coming in inheritance and all these related topics we've been talking about. This is where it all comes together. And I'm pretty sure your assignment's going to be this sort of thing where you're going to have maybe multiple types of air conditioners or multiple types of pizzas or something. And you're going to create an inheritance hierarchy based on those. And you're going to be creating an array like that, something like that, or an array list. And you're going to be getting user input and creating objects into the array. So that's going to be the assignments for this term, I think. So all this is very relevant for what we're doing in the assignments. Okay, but thanks for coming along, everyone. I think that's enough. I've banged on enough there about polymorphism and inheritance. And okay, thanks everyone for joining in, and I'll see you next week. Okay.
Thank you very much.
Thanks, Amy.
Thanks, Mike.
Thanks, Wayne. Thanks, Felix. Thanks, Lewis. Thanks, everyone who joined in.